welcome to Saurabh Sir classes. This is GET question 2022 statistics paper, question number 36, which says that let M be a 3 cross 3 symmetric matrix with eigenvalues -1, 1, 2 and the corresponding unit eigenvectors u, v and w. Let x and y be two eigenvectors in R3 such that mx equal to u plus 2 into v plus w and m2y equal to u minus v plus 2w. Then considering the usual inner product in R3, the value of x plus mod of x plus y squared, where mod of x plus y is the length of x plus y. So what we have here? We have mx equal to u plus 2 into v plus w, then x equal to m inverse u plus 2 into v plus w. Now why does this m inverse exist? Because you see that all the eigenvalues are non-zero, all of 3, -1, 1 and 2. So the determinant will be product of these eigenvalues -1 times 1 into 2, which is -2, so which is non-zero, so m is invertible. So x is equal to this. So m inverse of u plus m inverse 2 times m inverse of v plus 2 times m inverse of w. So if m has eigenvalue lambda, let's say m is eigenvalue lambda with eigenvector x, then the eigenvector a, then ma equal to lambda a, and that would imply m inverse, and suppose lambda is not equal to 0, then m inverse of ma is equal to lambda times m inverse of a, and that would imply 1 by lambda times a equal to m inverse of a. So if a is a eigenvalue of eigenvector of a with non-zero eigenvalue lambda, then 1 upon lambda is an eigenvalue of m inverse with eigenvector a. So here you get this is equal to, so this is 1 upon -1, which is -1 times u plus 2 times 1 upon 1, so this is 1 times v, so this is v, plus this is 1 upon 2 times 1 upon 2 of w, so this is equal to minus u plus 2v plus w. So we have got x, value of x. Now we have to find the value of y. So m2y is given to be u minus v plus 2w, u minus v plus 2w. So that means m inverse m squared whole inverse equal to m2u. This is equal to m2 whole inverse of u minus v plus 2w. So that means y equal to m inverse times m inverse of u minus m inverse of v minus m inverse of 2w, which is 2 times m inverse of w, all because m inverse is linear. So m inverse, this is -1, so m inverse of -1 of u is minus u, m inverse of v is v minus 2 times 1 upon 2 w. So again minus m inverse of u minus m inverse of v minus 2 out, so 1, so m inverse of w. So that means m inverse of u is minus u, so minus minus plus plus u minus m inverse of v, which is v minus half times w. So what we have, x plus y to be, what is x plus y? So x is minus u plus 2v plus w, and y is plus u minus v half w. So if you see, you can cancel out u, and your 1v, v2v minus v, 1v remains, and w minus half w, so half times w remains. So I have to find norm of this vector. Now see, m is symmetric. And then I want to claim that v and w is perpendicular to each other. Then v comma w, this is equal to mv equal to v, so mv comma w. Now this is equal to v comma mt transpose of m times e. Now m is symmetric, so v comma mw. Now since w is a eigenvalue of half, so what you get, this is half w. Now this is w comma v comma w. So that said, if you take this to the left hand side, what you get, half times v comma w, inner product of v w equal to 0. That said, v comma w equal to 0. So now you apply the Pythagorean equality. What do you get? What do you get? You get this with norm v square plus half times w norm v square. So this is 1 plus half times 1. So this is 1 plus half, which is 3 by 2. So I get 1 point. So half is 2 squared. This will be squared, so 4. So this is actually 1.25. 4 is 25, so 1 plus 0.25. So this is actually 1 plus 1.25, 1 plus 1.25. So that is option 1, option A.